which I have not done yet.
Recording in progress.
Okay, there we go. All right, so we'll start with 2.1. What is a function? So we put as a text box here. What is a function? Does anyone know the definition of a function? Okay, I'll tell you. Okay, no problem. It's a relationship between two variables such that for each input, there is exactly one output. So that's a function. Now, in this section, we're going to talk heavily about equations. Here's how you want to think about an equation. Equations are simply just relationships. Relationships between two or more variables. They don't have a summer job this year? Okay, yeah, summer job, Hugo. What did you do? Writing? Okay, great. What did you get paid? Sorry, I know I'm good.
18 and up.
That's Bob's. Yeah, I don't know. I gotta get high school pretty good. But let's say this though. Let's say actually no. We'll say I was gonna complicate a little bit, but so we'll say y equals 18x. Okay. I just made an equation. Where do you go say? What do you think the x represents? See, you said it makes $18 per hour. What does x represent? No, it's not dollars. Hours. What's the y? Money. So we got money equals 18 times hours, right? So if Hugo were to work 10 hours, how much money he makes? $180. That's a relationship. We found a way to relate the time he spends and the money he puts in his pocket, right? That's all equations ever are. They're relationships, right? So we found a way to relate the time he spends and the money he collects, or the money that's on his paycheck, right? Now, what if I put a slight wrinkle here? Let's say every week, Hugo just gets $100. Even if he doesn't show up to work, he gets $100. That's kind of nice. And then he makes, an hourly rate. Sometimes, like for example, if you hire a plumber to come to your house, sometimes they still charge you just for showing up, and then if they don't do anything, they leave, right? It's kind of crazy, but but sometimes we'll have to consider y-intercepts also, which we'll talk about later today. But that's a relationship, right? And for every x value, there is a unique y value, right? Like if he works 2 hours, he gets $36. So when y is 36, there's only one input. 2, right? Can he make $36 another way? No, he has to work 2 hours. If he works 1.9 hours, does he get $36? No, he gets a little less. If he works 2.1 hours, does he make $36? No, gets a little more. So a function is when you have a relationship, which we just explained what a relationship is with variables, but it's in such a way where for every input, there's exactly one output. So like, look over here, right? Like with x is some number, there's only one y value goes. But here we have a problem. Let's say this is actually I'll give you an equation for this. What about x equals y squared? I think that would be a potential equation for this one. So let's say x is 4. If x were 4, what could y be? If x were 4. In this equation I just wrote. 2 or
-2.
Exactly. Good. Now, how many outputs did 4 have?
2.
Yeah, 2 and -2 outputs. Is that a function? No. Because you have to have exactly one output for each input. So that will fail to be a function. A function is only true when there's only exactly one output from one input. The best way to check it, I know it could be kind of confusing and kind of abstract. The best way to check it, most visual way, is draw vertical lines. If you draw a vertical line where it touches more than once, then it ceases to be a function. Like that all ceases to be a function. This vertical line touches twice. Because whatever x value this is, say it's 4 again, there are 2 y values that that's not okay. You can't have 2 y values go into 1x. AJ, go ahead.
So when we like
Yes. So horizontal line, that's the opposite situation. That's called we call it one-to-one functions, and there's something called an inverse. We're not going to talk about that until the spring, but that's something we are going to have that discussion down the road as well. For now, we're just doing vertical lines. Yeah, but that's a great observation. We are going to have that discussion down the road. Other ways you can look at it are mapping tables or graphs. So let's look down below. So when you have functions, you can use like a mapping diagram or a table or a graph. You have to guarantee that for every input, there's one output. That is kind of worry a little bit. Years ago.
Wait, I have a question. So is this one, the one on the far left, also not a function?
That is a function.
It is.
This vertical lines touches once.
Okay.
Yeah. So what if I had? So each of these are functions. These are.
Oh, well, it's right there.
But let me make some slight alterations to these diagrams here. And not make them. What if I got rid of this? Have that. See that 0 has 2 outputs now, right? One way to think about this is very corny. I taught freshman Algebra 1 17 years ago. It's kind of like you can't be in a relationship with people. That'd be kind of weird, right? What's that? Oh, okay. Yeah, I mean, so I watch quite a bit of Netflix. Have you guys watched the show Never Have I Ever? That one? Yeah, the star, like she actually has 2 boyfriends in the show, like for like every episode. You can't do that. You can't have 2. You can't really do 2 people. So you'll find out. So I know it's kind of corny, but anyway, monogamy is a good thing. So, anyway, no polygamy. And I watched that other show, that one about the Mormon guy in Utah who had like 50 wives.
Oh, like Sister Wives.
Yeah, that's just nuts. That's just nuts.
I watched that one.
Yeah, go ahead. Yeah, they are the full system. So anyway, only one. Right? Now this would not be okay. Also, you see the problem with this? Theta 0 has 2 outputs. That's not okay. Or if you had this here, that would not be okay. To see, you got these 2 dots here that are right above each other. One's right above the other, so that's not okay. Or if I did this, that's not okay. I can't do 1, 2, and 1, 3. For every output, so for every input, it has to be just one output. So all these are functions because I guaranteed that x never repeated. Another way to think about it, x cannot repeat. X cannot repeat. Okay? Hey, good.
If there's like if there's like multiple outputs, is that okay?
That's what. Yeah, I mean, if we had this here, that's okay.
Okay.
That's okay because then you're going to plot 0, 2. Great question you brought up. That's okay. So if we're in Utah, you can think of this as the man, the woman. You know, like well, actually, no, that wouldn't be okay. No, this would be the woman, this would be the man, I guess. I don't know. Anyway, I'll stop. I'm talking relationship. Exactly. Yes. Yes. I was trying to get the gender stuff, but let's just not worry about it. Only one output, the output can repeat, as you see right there. Yeah. Now, 2 terms that we're going to talk about a lot in this class. You probably have heard of it, maybe haven't, but I'm going to tell you right now. Domain and range. Domain's going to be X. Range is going to be Y. So the domain, and it's already defined for you down below. You don't have to write anything. It's all the possible X values you can get from a function. The range is going to be all the possible Y values you can get from a function. So let me give you some examples here. Okay, I'll give you a couple examples. Y equals root x, y equals x squared. I'm gonna graph this in Desmos. We're gonna answer these questions about domain and range.
Wait, so is y just the highest point of y and the lowest point of y? Or the range?
The range, yes, exactly. Yes, you got it. Yes, yes. So the range is going to be the highest, lowest values for y.
What about in between?
The domain, no, and everything in between also, right? The range, so the domain is going to be all the x values from left to right. But let's graph these right now. Let's go to Desmos. So y equals x squared. Okay. Let's look at y equals x squared. Let me erase this.
Wait, you write it as an inequality.
You do, yes. So y equals x squared. That's what I have right here, right? Domain. Range. Okay. So when you look at y equals x squared, is there any reason why there should be a restriction on x? Or all x, or would all x values be included? Can I plug in anything I want for x here?
Yes.
Sure. There's no reason for any restriction. You can plug whatever you want for x. Like I can plug 1.56, I can plug like 2.87, whatever, right? So you would say that would be all real numbers. For range is y. Is there a low point? Is there a bottom? Is there a basement?
Yes.
What's the lowest y coordinate? 0. And what's the highest y coordinate?
All real numbers.
Goes up forever. The range, you usually want to look at a graph, just so you know. To determine range, consider it graphically. For domain, consider restrictions such as denominators or square roots. Usually for domain, you have to consider restrictions such as denominators or square roots. For example, what if I switch this up now to y equals root x? Okay, there's the graph, the square root of x. Now think about it. Can I plug in -4 in here?
Yes.
You could. What's square root of -4?
2.
No. What's 2 times 2?
Oh,
4.
4.
Not negative 4. Can you think of two identical numbers, two identical real numbers that can multiply -4?
-2 and 2.
Those are not identical. Right?
Uh,
I got you. So you can't. So that's a restriction. Look at the graph also. The graph starts where?
yeah.
At x equals 0. So we're going to say our domain is x greater than equals 0. So there is a restriction. And then consider graphically, is there a low y value here? Low y coordinate? What's the lowest y coordinate here?
0.
And then it rises forever. It rises slowly, but it rises forever. So the range stays the same. So that's kind of what's going on with domain range. And we're going to talk a lot about this down the road. We're going to revisit these functions over the next few months. 1/x. Let's try one more.
Whoa.
Yeah, we won't do this till spring. And I'll be back by then. 1/x.
Whoa.
Now in this case, this is kind of a weird one. Is there a restriction? We have x in the denominator. Is there a
No.
value that you cannot plug in?
No. Yes.
Yeah, which one can I not plug in? You cannot plug in 0.
Yeah.
So you would say all real except 0. And actually the range is the same thing.
Because if x was 0, it would be undefined.
Exactly, got it. Right. Looking at the graph, I see that y is not equal to 0, which actually would be impossible because the top is stuck at 1. In order for a fraction to be 0, you need a numerator to be 0, but a numerator is stuck at 1. So these are things, again, don't worry if you're still trying to make sense of this because we're going to revisit these functions down the road. But domain just means the x values you're allowed to plug in. The range is the y values you're allowed to get x. So where are you allowed to put in? Where are you allowed to get out? That's domain range. But we're just introducing the concept for now. So let's move forward. Okay. All right. This stuff I feel is more tangible and more mechanical because these are things you have seen before. Slope, I'll tell you right now, is the most essential topic in high school math. It is the most essential topic. In calculus, believe it or not, calculus seems like eons away. You probably do calculus 2 years. I've taught calculus. Slope defines the whole first semester of college level calculus. So it's a big deal. But not as one. And it's just a rate of change. That's all it is. So slope is the rate of change. So let's go back to ego salary, which I left on the board. Okay. So y equals 18x. What will be the slope for this equation here? Do you guys can you guys recognize the slope in this equation here? 18. And why is that a slope? Because think about change in y over change in x is 18, or the change in money over the change in time. If you decide I want to work 2 more hours this week, how much more money is it going to make? $36, right?
Wow.
It's a rate.
Got banged.
It's a rate. So slope is rates. You have an hourly rate. That's all it is. So you're looking at the change in y or change. I know this is very dry and boring. Nothing's more interesting. But change in y or change in x, where y in this case is money, x was time. But generally speaking, it's what change y or change in x, right? Rise or run. So you simply subtract the y's and subtract the x's and divide the 2. That's gonna be slope. And we call it rise or run because either you're rising and you're running this way, or you're falling and running that way. So here we have 4 types of slopes. We have 4 types of slopes. So this would be positive. This would be negative. This would be it's a horizontal line. So it's 0 slope. This is a vertical line. This would be undefined slope. That's undefined because then you're divided by 0. You have no change in x. So undefined slope because no change in x. 0 slope because no change in y. So let's think of real life examples. Positive slope, your work, right? You work more, you make more money, right? So that'd be a good one. Anyone have a good example of a negative slope? Did you got an example?
Yeah, I was actually going to say like spending money.
True. Yeah, exactly. If you're not bringing any money in. Another one could be, I like to say, hours of sleep in GPA, perhaps. I don't know if that makes sense, but the less you sleep, actually, no, sorry, take it back. Hours playing video games and GPA. I'll take that back. Okay, someone would look at me like you're crazy. But but if you were to play more video games, probably your GPA might go down. You probably wouldn't have enough. I mean, I could be totally wrong. But you want something that's going the opposite, right? So that's what's happening there. Or actually, no. This is a true example. What happens to car values as time passes? Do cars appreciate or depreciate?
Well, if they're good cars,
They're not classic cars. Not classic cars.
they're collectible, they increase.
Okay. The cars I see right now, I see a few Audis. I see like those cars are going down in value as time passes. So that would be negative. Okay. Horizontal. Okay. What do you think about horizontal? Any good real life examples of horizontal stuff? Anyone spend time in San Diego? Anyone been down? Okay, what's the temperature in San Diego usually? It's about the same. It's about like in December, it's about 75 degrees. In July, it's about 75 degrees. It's beautiful. I did my undergrad in San Diego. So anything that stays the same. Or say you're driving from here to LA, and like when you're on the highway, sometimes you drive like consistently 80 miles per hour. So your speed would be a horizontal line, right? Because you're keeping the same speed if you're on a long stretch of highway. This one is weird, so let's not worry about it. Let's keep moving. The numerator is 0. No change in y. We get cold. It get cold here.
I think those like in the morning.
You will quickly find when you guys head off to college, if you guys go to the East Coast, how awesome California is.
Oh, I love.
Yeah. Well, I spent 2 years in Oregon where it rained all the time, and then I was so happy to come back to California. So
It is. I don't like
California's pretty awesome. Just very expensive to live here.
I don't like
How hot it is here?
Dude,
Yeah, just go down to Arizona. try that. Or go out to the valley or Fresno. Okay, let's keep moving. All right. Other things you got be concerned about too. Which you guys have seen before. You gotta add control slope. Same parallel lines. When you're parallel, you can have the same slopes, right? Like parallel parking. My dad said that he parked my lane. My dad parked the car like total shit last night. I had to refix it. He was like parked at a corner. I was like, Dad, what are you doing? Like, oh, the car's gonna hit your car. They live nearby, but when you parallel park, right? You have a curb. You want your car parallel to the curb, right? Otherwise, you might get a ticket. So parallel means same slope, right? They have to be going the same direction. Okay, same slope. Perpendicular, negative reciprocal slope. Negative reciprocal slope. This is a tricky one, but like this were 4, then this is -1/4. You gotta change the sign and flip it when it's perpendicular. So see, it's +4/1 and -1/4. So whenever two lines are coming at a right angle to each other, the slopes are always related in that manner. Where if they're parallel, they're always going to be the same. And that's, I think, pretty obvious, right? Like if you're parallel parking a car, you're going to park facing the same direction as the curve, right?
Wait, so they're just like switched?
Yeah, what happens is that you switch the numerator and denominator and you change the sign. Yeah, actually, yeah, flip and switch. There you go. All right, now let's actually do some computations. I think we got 2 examples here. Yeah, 2 examples. Great. All right, let's look at this one. So all you're doing, you're gonna calculate the slope. We use the letter M for slope. M's the letter we use for slope. It's a change in y and a change in x, or -2 minus 1 over -3 minus 6. That's all. -2 minus 1 over -3 minus 6. Or you can do this, or you can do 1 minus -2. Either way is fine. Yeah. So actually, AJ brought up a great observation. If you want to do left coordinate minus right coordinate, and you do left minus right for x, or if you want to do right minus left for y, you better do right minus left for x. You got to be consistent. However, I don't care, because you're gonna get the same thing each way. -3 over -9, which is 1/3, or 3 over 9, which is also 1/3. Either way, you get the same thing. What you don't want to do is you don't want to do -2 minus 1, then 6 minus -3. You got to be consistent, right? So, but that's a pretty easy calculation, not that hard. Boring also. Let's do something a little more interesting. Let's look at the fuel efficiency one. All right. So on Friday, for a weekend camping trip, 110 miles on the odometer, 14.5 gallons of gas in the tank of your car. When you returned, the odometer at 299, and you had 7.5 gallons of gas left. What was the fuel efficiency? So all you're doing, go.
Well,
You drove 180 miles.
Right.
189 miles,
Right.
and it took 7 gallons. I guess you have a 189 over 7 gallons.
Okay, so for those who, it's actually a really good question. So, who drives in this class? Yeah. So, do you guys see when you drive, usually somewhere in the front or somewhere in the center, usually miles per gallon, right? What is usually miles per gallon for a car? What do you guys usually think? But what's a good miles per gallon for a car? How many miles should you get per gallon usually? Does anyone know? No? Okay. Usually about 20. Go ahead. Yeah, about 20, 25, 30. If you go on the freeway, you tend to get better mileage. If you city driving, or if you just drive like a maniac, you probably have terrible. If you're a hybrid, you're really good. Yeah. Or you could be electric and don't have gallons. They could do that too. But then you're looking at now charge, right? A little different thing. But in this case, you're doing 299 minus 110 or 14.5 minus 7.5 or 189 over 7. Which I don't know what that is. What is 189 over 7? 189 divided by 7. Oh, wow, came out really nice. 27 miles per gallon. Okay, that's pretty good.
27 miles per gallon. That's pretty good.
That's very
Yeah.
good. That's some good fuel.
Well, you're probably driving at a normal speed, not driving 100 miles an hour, which can ruin your mileage. But, okay, questions on slope? All right, let's keep moving. Let's keep moving. Okay, graphs of lines. This is pretty dry stuff, but we got to talk about it. There are two. Well, we'll talk about this equation right now. So you guys see this equation before? This is not new, hopefully. Y is not to speed. M is a slope. E is a y-intercept. Very easy. Plot y-intercept and use slope to get additional points. Very simple. Plot y-intercept. Use slope to get additional points. That's all. So y equals -2x. Perfect. You can think it's +0. We don't put the +0 because it's redundant, but you could. So what's y-intercept here? 0. What's the slope? Perfect. So you're gonna locate 0. Then you can go down to right 1. Down 2. And you can keep doing it over and over again. Little scale line. There we go. That's all. It's super easy stuff. Super easy. Here, you can think of y equals -1 times x plus 5. This notation, are you guys familiar with this notation? What this means?
Yeah.
Function of
Yeah, we say f of x. We'll talk more about functions down the road, like function notation, but it's the same thing as y, just so you know. So f of x. You've seen that before? This notation. Yeah, it's the same thing as y. Yeah, so don't get confused by it. It's just another why we have this notation. I'll have that discussion at a later time. Just y. Yeah, just think of y. Don't think of anything else besides y. It's just y. So when you see this, think of that as y. And it's a little reversed, but you can think of it as -x plus 5. Same thing. So like if I have 4 plus 1, 1 plus 4, same thing, right? So -x plus 5. So your slope's -1. Your y-intercept is 5. So 5 is right 1, 2, 3, 4, 5. Down 1, right 1. Down 1, right 1, down 1, right 1, down 1, right 1. There you go. There's a line. So again, it should be all review. There should be nothing new. Ask if you guys are stuck. But graphing lines, if you have it in slope-intercept form, and we call this slope-intercept form, just so you know. We call this slope. Intercept form. Where y is isolated. Now you're probably seeing, guys, quiet please. Now you're probably seeing why we want to isolate y. If you have an equation with like say, you don't have to write this down, but like say you have like 2x plus y equals 10. It would help to get y by itself, because if I get y by itself, then I can easily identify the slope and y-intercept, right? Because now it's in this format. So this is why we spent that time in the previous chapter isolating variables, because we need to make sure we can quickly identify slope and y-intercept. Everything builds upon itself in this class, right? That's how math works. Questions on how to do those graphs? No? Okay, we'll keep moving. We'll keep moving. Okay. Standard form. And then we'll do 2.4. Yes, thank God. But they're all intertwined with slope and 2.3 are pretty close to 10 and 2.4 is close to 9. So all right, let's talk about this stuff here. Standard form is another way to write a line. Some people prefer to write lines like this. I'll give you a good example. You've probably seen these word files before, but like, say, like we have the fall musical coming up. It's Sound of Music. I heard that. Or no, it's actually Janitor. Yeah, I was hearing that one song from Sound of Music, Fuzz McGaney. Like it's like dear no blah blah blah. But how's the song go? Yeah, there we go. Okay, so they'll sing, please. But it's driving me nuts. But we have the point I'm trying to make is that when we have the fall play, we have to charge money for people to come watch it, right? And we usually have two different prices. We have a price for adults, a price for students, right? Sometimes we want to write equations like that. Like, what if it was like $4 for students, and what if it was like $10 for adults?
Whoa!
Crazy. I almost fell. And the same way bucks, right?
That's a scam.
Sometimes we want to write equations like this. Sometimes we want to write equations where all the variables on one side and just the numbers on the other side. Sometimes we like writing equations that way. We'll have that discussion in chapter 3.
Right.
That's why I robbed right now. Okay. But anyway, 2x plus 3y equals 12. What I would do is isolate y. Okay, so what did I just do? I decided to get y by itself, because by getting y by itself, can I identify the slope now? What's my slope? What's y-intercept? 4. You look at 4. Go down 2. Down 2. Right 3. Down 2. Right 3. Down 2. Right 3. And that's how you graph. So again, just to be consistent, when you graph lines, try to get them in slope-intercept form. It's much easier. You have y isolated. It's a really nice, neat equation. You have y on one side. You have all the other junk on the other side. The other junk, we can interpret it as maybe 2/3 of the slope. 4 is y-intercept. 4 is where we touch y-axis. Negative 2/3 is how I rise and rise. If it's negative, so I gotta go down instead of up, right? Gotta go down 2, right 3. By the way, could I have gone up 2, left 3? Sure. I could have gone up 2, left 3. Same thing. You put a negative both top or bottom, your choice. Don't put it both places, because that would be positive 2/3. For the negative to go to the numerator denominator. I prefer to put a numerator just by habit. But yeah, down 2, right 3. Down 2, right 3. But you can also go up 2, left 3. You do that also. Your choice. There's another technique called the intercepts method. If you so desire, I'll just show it to you just so I've talked about it. If you so desire, you could have done this also. You could have done that also if you wanted to. If you want to plug 0 for y and solve for x, or plug in 0 for x and solve for y, it's the same. If you wanted to, you could do that. Yeah, good. Yeah. So I just wanted to share that with you, but I prefer that we be consistent. Let's get y by itself. Those are good. So, it's your choice. I'm just showing you. Well, all I care about is you get that. You know, but I think the more efficient way is getting y by itself. It's a more universal technique.
Wait, hold on.
Question?
No.
You good?
Yeah.
All right. Okay, last section. Rapid fire today. Okay, one more type of format for a line. This is called point slope form. Point slope form, which I'm sure you guys have seen. Now, even though I like slope intercept form, in calculus, as a calculus teacher, I actually would much prefer my students use this form. Because once they get the slope and they have a point on the line, there's nothing else they need to do. They could just leave the answer like that and just move on. Because sometimes you could make careless mistakes and move things around. On the College Board, if you do take AP Calculus in a couple of years, they kind of would much prefer you write equations this way. But you could isolate y also. But it's a really simple formula, point slope form. The point is x1, y1, and the slope is m. So you have m, and you have the point. Here's all you write: y minus 5 equals 3, x minus 2. Done. Just plug and play.
So you can we leave the answer like that?
Yeah, boy. Unless if I specify on a test, like, hey, give me the answer in point slope form, in slope intercept form, then of course you have to rearrange. But if I just say, here's some information about line, give me the equation line, I never specify, you can leave it like that.
So we just have to find like one point and then release this down.
Yeah, fully. Here's another one. Now, I don't know the slope. So how am I going to find my slope here? Yep, 10 minus 1 or 2 minus 5. Or you can do 1 minus 10, 5 minus 2, same. So then you do this. Y minus equals -3, x minus.
You can choose like whichever.
You choose, yes. Yes. You can use either point for x1, y.
Y minus.
It's up to you.
So would it be y minus 5 equals -3 parentheses x minus?
No, because 5 is an x coordinate.
Oh yeah, that's right.
But you can do this.
Y minus 1.
Yeah.
Wow.
Or you could do this. Y minus 10. Or you do that too. Either way, you're going to get the same thing when you isolate y. You'll get the same thing. I think so. 6, 16. Yeah, you get the same thing. So either way is fine. All right. Let's try 2 more. Any questions on the first 2 problems I just did here for 2.4?
We're okay? I'll give you guys a chance to copy.
Let me erase this other side here.
We're good? Okay, cool. All right, last two problems, and then I'll give you guys some work to do. Write an equation that passes through this point and is perpendicular to that line. Okay. So what I'll probably do is get my slope first. Now I know I've covered a lot of material today.
About to cover half the practice too. But I'm gonna erase the words here, sorry. What did I say about perpendicular lines, about the slopes? What was the
Same slope.
negative slope? So look at this line, that was perpendicular. So we're perpendicular to that one. What's the slope of that one? So what slope do I want?
-1.
-1/2, yes. Sorry, that means. Thanks, Lizzie. And everyone else. -1/2, right? So
I'm gonna do this.
Here's the plug in, right?
Y minus -5 equals -1/2 x minus -6. And just clean it up a little bit, you know, make it look a little nicer.
And by the way, the instructions specify what form they're write in. So you can do whatever you want. So if I were to take out the point, I wouldn't want form, but I can specify, then I want to empower you guys to challenge me. And you know, sometimes you know who you remember is going to be attorneys, who actually is good at arguing points. I actually have some former students who are now work like assistant district attorneys at other. And I knew they're going to be those people because they were so good at arguing points and other stuff when they're students here. But if I don't specify, then I can't take up points. Right. So you know, put your lawyer hat on. If I ever take out points, then I should have to take out points. But I usually try to be careful with what I write tests. If I want something in particular, I'll make sure I'll state it. But I didn't state anything. I just write a equation. So be like that. If you want to get y by itself, fine too. Get y by itself. I don't care. But the bottom line is you have to have something that's correct, right? That is correct. I have the right slope and I have a point that's all.
So even if you left it like this up above, that's fine too. If I didn't say simplify it, that's fine too. Then you're asked to write one that's parallel. That's an easy change. Super easy change. If I want it to be parallel, what's my slope now? 2. There we go. One advantage of point slope form
Is that if you have to write multiple equations, you don't have to do one little change, same slope. If I were to isolate y, and then it's now give me another equation that's parallel, then I have to do the process all over again.
That's why point slope form is kind of advantageous. Is that if I were to say, find me a line that's perpendicular, great. And now find one that's parallel, you just have to make a small change. So it's a really easy change. So you have a little more flexibility with point slope form. That's why it's kind of a good form to have. But that would be 2x because you have a parallel. All right, last one. Okay, standard form was ax plus by equals c. So the first thing I'll probably do is start with what form? Yeah, thank you, Hugo. I totally in agreement there. Because you're given the slope and y-intercept. We might as well just start with that. So y equals -3x plus b plus 5. However, now this is where in the fine print, I want standard form. So you're gonna have 3x plus y equals 5. Because you have to get x1 6, so that's it. So 3x plus y. All right, that was a lot of material. So I got 2 more classes. I'm gonna go kind of easy on the work.
You rely on caffeine. Yes, I rely on a good sleep schedule.
What time do you even sleep? Like, I mean,
30.
what?
I usually get better.
You go to bed at 9:30?
Latest how it goes.
Should be. I'll double check. Let me tell you what problems I want you guys to do. Give me 1 second here.
I usually sleep like 10:30.
Okay. Here's what I want you guys to do. 2.1. Numbers 3 through 6. All. 2.2.
I'm sorry, did you say that you want homeschools or what?
It is. Oh, then I'll give me a sec.
No.
Okay. And let me see if it's in school, Jake. Hold on a sec.
Tell whether the relation is a function.
Good. So Cam, were you asking if it's in school, G? It is there. Click on problem sets. Problem sets.
If it's
Number.
Oh, the assignment. Yes, I'll put that right now.
No, because two of them equal to negative.
Yes, Hugo, go ahead.
If it's the y, if there's two of the same y value, if there's two of the same.
That's yeah, no, that's okay, but you can't have x twice. X can't repeat.
And if it's negative 2 and 2, it's fine.
That's fine. Yeah.
So it's fine.
Yeah, so it's a function. Yeah.
Yeah. The next one.
Or is it not? Is it like?
Yes, because everything is.
Negative. It's negative. Y, negative 2. Negative y.
X equals -1 twice,
Negative.
which means it is not a function.
Yeah, it's not a function. No,
That's what I do. The first one is definitely. First one is
The second one is. That's fine. Number 6 is the same.
pretty sure.
Yeah. It's a function. Yeah.
It's like.
No, it's pretty obvious. Okay, 6, 9, 2.
1 through 8. All.
Yeah, I just like get all of these numbers, which is
1 through 8.
I'm not saying.
The graphs that might be hard to do the graphs. I don't know.
One.
Wait, 1 through 5.
Oh,
is
no,
slow.
no.
One is slow. It's just ugly. Points.
Wait, what's
That's crazy.
what's on the top? Is it X on the top or?
I think it's changing one over changing.
Mm-hmm. Thank you, Ryan.
So it's two things.
Negative.
I got two. So y equals, no, it'd be y.
So it's, I'm getting three outs.
Okay, the formal assignment's also up in Schoology as well. All right.
I got 3 outs also.
My stupid way.
Yes, you are, clearly. Oh, no.
Number 2
Then tell whether it rises the first one. Number 2. Oh wait, dude, let's just skip and do the easier ones.
Yeah, let's just skip.
Not do.
It's just.
We'll still
Here's
do
one
it later.
Plus 5 4 minus 3 4.
I'm gonna
Would it be minus or plus? What's that question? Is it
Negative 4 minus.
Is gonna be
I got 1
negative 1 over, what the hell? Negative 1 over 8.
What you do?
Negative 1 over 2. Oh, you guys are doing number 2? Yeah, it's actually not that bad. I do it. And then it goes down.
Negative. Negative 1/2 of.
Patrick, I don't know what to do with your math. It's change of y over change of x.
Yeah, you tell them.
Yeah. I forget. Stop making fun.
Okay, number.
Not okay.
Number 3 is undefined and it's vertical.
It's not.
Okay.
It's negative 3 times 5 over change.
5 or
Negative
So you go from. You stop at you.
Y 2 minus y 1. Yeah.
I know the
Just leave it right here.
No, if you go to the helper. Wait, serious? You never got that. Why did we switch?
That's only if you're doing change. If you're doing minus.
Yeah, well, it's the next one.
You could probably pull up the range.
What is the next one? Undefined.
Oh, 4. 5 4 plus 0. What?
4 minus 2.
0 over 4.
Oh, crap.
That's a vertical. Do you guys get negative 1/2 for number 2? Yeah. For number 4, did you get vertical? I mean horizontal. You guys are on 4?
Axis on the bottom.
What should we do?
Hold on.
And that's what we got. You get 5.
I'm gonna go 2 get 3.
I'm just gonna do
Hold on, bro. How are you guys so?
We on the grind.
I just want to get this homework on.
I actually.
I want to get it out of the way.
No, the next one's we have to graph the equation.
When we do.
Yeah.
Bro, like,
Yes.
this sucks.
Can I just make like a huge graph here and then plot all of these on that
Sure.
graph?
No, like terrible idea.
It's not a terrible idea.
Or you could make mini graphs. When they were done. Or you could do a web graph and go into one of
These cost them $9.50.
Yeah.
I mean, it definitely does.
I think that might be a large graph. Yeah, but no, but that might lose track. You guys got 0 to the slope for number 4 in there. Yeah.
I might just do 4 mini graphs with like 2 people.
Yeah, they were like down.
Negative x minus plus x. Wait. So it's at negative 3, then goes down by 1. Yeah.
It's not like instructions or code.
Whoa. Whoa. What do you mean?
Right now, bro. Bro, there's no graph provided either.
No.
If you're not. Oh, yeah.
Oh.
Like.
Wait, Kenny, you tell me. He makes me look. I'm moving on to the. And what?
Wait for what? It's not like what it is.
Wait.
You go.
Hold on, bro.
Why is it second to the top of that one?
Yeah.
No, it's so the house.
Welcome to mystery.
What's up?
Do y'all like graphic?
I don't, unfortunately. Yeah, bell's gonna ring in actually 30 seconds, yeah.
Well, you made it done, bro.
I'm too lazy to do it.
I gotta make a hike. I gotta make a hike to second floor main. So I have to go to Thursday.
From A to B, I gotta go third floor.
Bro, I gotta go to. I go from good thing. I had the equivalent of 15 minutes to get from other side of the hall. I wait on the couch.
Yeah, I think, I'm gonna concentrate on
It's honestly.
yeah, seriously, here's something that many parties, something you like extend the time.
My faster is so damn party. Well, I get like 30 bucks. I want to know how much, like you're driving and they'll be right, but after like, oh, it's not so much. I don't know how it's even possible.
No.
It wasn't a singular one.
Really, that means you like waited.
I love
Literally got parties back to back.
I only get the whole, the thing late to the start.
I had in my C and D period and they were late to both.
Dude, I want to take it now. Hold back.
Then go to health and wellness.
Give me another two.
Well, morning.
Hey, how's it going?
How are you?
Good, yourself?
Good.
Good.
Just a little tired. I feel like today feels like Friday.
I know it's Wednesday only. I know. No. Hey, what's up?
I can maybe like sit on this screen thing and charge my iPad.
Sure. Yeah. Yeah.
I'm gonna go to the restroom.
Okay. No problem.
Like, where are you going? Wait, what? Hold the table.
Morning.
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 No. That was really hard. I'm struggling. Yeah, because Jordan could explain to me and I was like. I think I need to borrow my iPad today. You can send it.
Geometric shapes. I was gonna do like, why are they gorilla then? Why not? He said there were special shapes. That's what everyone did, not gorillas.
Oh, yes. What's going on?
I was struggling with the ones where it was like the tangent and then the SEC ones. Like
Mhm.
I was getting answers, but then I'd plug it in the calculator and it'd be something.
What mode are you on?
I don't know. I was
Do you have
using
a
it
calculator with you?
online. Yeah, I do. I was using it online.
You just have to make sure whatever, can't tell. Maybe you're doing all the others, you're like in degree mode, you're playing radio, so you get to switch different.
Like I would get like. Yeah. Oh, you can't.
I mean, you might.
Oh, I can't have.
You might get that stuff, it's okay. You have to match it up with.
Then I can percentage number. Oh, wait.
Okay, so you're talking about the.
No, it was.
Okay, so angle 7.5%, right?
Yeah.
So chill. 7.5.
Another year's at a point.
And then, so right now we're in green mode, so let's switch out to radio.
How do you get that?
Mode. I'm used to go down. And there you go. Now, obviously it's a weird decimal, right? On the issue. On the other, it's gonna say, like,
I think I had a read. Yeah, now I understand why I forgot you had that. Oh, I found it.
You got to pull that one perfect. Okay. Yeah, so 7.5 6 right there.
Yeah.
And tangent y for x
So doing this coordinate or that coordinate,
And then you flip that.
which will be 1 over root 3.
Yeah.
And then if you were to rationalize the denominator,
Root 3 over root 3.
so exactly, and then you'll get that. Yes.
Yeah, I forgot when I was.
Yeah, we're gonna review it today. You'll do it again.
Thank you.
Yeah, no problem. All right, I saw Iris, 7, 11, 13. Well, everyone's here. Okay, great.
The first one that work are like if you know it's like, oh, CFC like 1 over or y over 1.
Mm-hmm. Yeah. Yeah. Are you a North Carolina fan?
I am.
Yeah, who they beat in the championship? It was
This year?
yeah, last year. Yeah. Yeah, who they win? Who they beat? It was North Carolina lost to Kansas. That's what it was. That's what. Sorry, that's right. Yeah, that was a good game. You know, there was a Kate Garlinghouse went to that game.
Oh yeah, they're big units.
Well, I mean, like, and she flew in the next day. I'm like,
But it's not, they're Kansas people.
I know, but I was just like, wow, like you're at the game just like 8 hours ago. Yeah.
UNC's really wants to.
Are you thinking about applying there?
No, I'm going to Naval Academy.
Oh, great, awesome. Okay, that explains all the Navy.
Yeah,
Got it.
I got that Navy.
Sorry.
On top of that.
No, I couldn't find that one. I don't get our schedule. Why are we sending this?
I know everyone's asking about it. I don't know. All right.
I was already.
Yeah.